Hey guys, what's up? We're going to look at beta decay. So as we've seen before, nuclear radiation is radiation emitted from unstable nuclei. So here's an unstable nucleus. It's simply got too much energy as a result of its mixture of protons and neutrons in its nucleus. And it wants to become more stable because that's the way the universe goes. And there's four ways it can do this. It can do alpha, beta, gamma, and neutron decay. Today's video is going to focus purely on what happens in beta decay to enable nuclei to move from unstable to more stable nuclei. So let's look at an example of a beta decay. Here we've got carbon-14. It's an isotope of carbon that's got a couple of extra neutrons. So let's have a look inside this nucleus. It's got an atomic number of 6 carbon, so it's got 6 protons. And it's got 14, the atomic mass, take away the atomic number, which is 6, so it's got 8 neutrons. And this is unstable. This configuration has got simply too much energy, and this carbon wants to decay. The nucleus wants to become more stable. And to do that, it emits a beta particle. So this here is our beta particle. And a beta particle is simply an electron. So an electron somehow is kicked out of the nucleus. And you may be questioning, but electrons don't exist in the nucleus, and you're right. It's actually a little bit more complex, and we'll get on to where this electron actually comes from. It's not from the shells and the orbits and the energy levels around the nucleus. So let's have a look. The carbon has decayed into nitrogen. Nitrogen has an atomic number of 7, so it's now got 7 protons. And 14, the atomic mass, take away the atomic number of 7, means it's got 7 neutrons. So you can see here, carbon has decayed into nitrogen and it's emitted a beta particle. But there's been a change in the nucleus. One of these neutrons has actually turned into a proton, and that's why the atomic number has gone from 6 to 7. So let's just have a look at what's actually going on. A neutron has turned into a proton plus an electron. This is fine because neutrons are neutral, they've got 0 charge, and protons have a positive charge, and electrons have a negative charge. So before we start with 0 charge, and after we still ended up with overall negative charge. And because this electron can't exist inside the nucleus, it's kicked out, it's emitted as an electron. So this electron is kicked out, and that is your beta particle. The proton stays inside the nucleus, and that's why the atomic number has gone up by 1. So in terms of what happens in beta decay, a beta particle is emitted. Let's have a look at what happens to the mass number. The mass number is the same. We started with an atomic mass of 14, we ended with 14. And that's because the amount of particles in the nucleus, the amount of nucleons we call them, has stayed exactly the same. We had 14 to begin with in the carbon, and we still have 14 in the nitrogen. But the atomic number has actually gone up by 1. And that's because a neutron has turned into a proton and an electron. And if you remember the definition of the atomic number, it's the number of protons in the nucleus. So because we've got an extra proton, the atomic number has increased by 1. Let's have a look at another example. So here we've got iodine 131. It's an unstable isotope of iodine. So let's have a look inside this nucleus. It's got 53 protons because its atomic number is 53. And its number of neutrons is 131, the atomic mass. Take away the atomic number of 53, so it has 78 neutrons. This decays from an unstable nucleus into a more stable nucleus. And it kicks off a beta particle, which we know is just an electron. An electron has a mass of 0 and a charge of -1. So the symbol for a beta particle is this, and this will enable us to solve any of these decay problems with beta decay. So now all we need to do is consider how many protons and neutrons there's going to be inside this xenon. Well, we could do it two ways. We could simply remember a neutron turns into a proton, but I'm going to do it by looking at the equation. We've just got to make the numbers on the left equal the numbers on the right. The mass is unchanged in beta decay, but we've got to make the numbers on the right for the atomic number add up to the numbers on the left. So we're going to have 54 here, because 54 take away 1 is 53. And if we now look inside the nucleus, we've got 54 protons and we've got 77 neutrons. And that's because, as we've seen in beta decay, a neutron inside the nucleus is decaying into a proton and an electron. There's something else that I want to mention here. And it's the fact that what is happening is transmutation. And this occurs in every single beta decay. We started off with iodine and we ended up with xenon. A new element is made. And that's because the proton number, the atomic number, has increased by 1. And if you change the atomic number, then you change what element that you have. So we started off with an isotope of iodine and we end up with an isotope of xenon. So let's have a look at a few more decay equations. We won't go into the detail of everything that's going on inside the nucleus. We're just going to do this because this is what you'll probably see in the exam. And the key bit to remember is that the symbol for a beta particle is 0, minus 1. So we've got 32 phosphorus 15 and it decays emitting a beta particle. And you just got to make the numbers on the left equal the numbers on the right. The mass number is unchanged and the atomic number goes up by 1 because 16 take away 1 is equal to 15. Here we've got strontium decaying into yttrium and a beta particle. So beta is 0, minus 1. So we know that the mass stays the same, it's 90, and the atomic number goes up by 1, so it's 39. Finally, rubidium decays into strontium and a beta particle. Beta, as we know, is 0, minus 1. The mass number stays the same, and the atomic number must increase by 1. So always remember 3 key facts. 1, the mass number stays the same. It does not change, and that's because electrons have 0 mass, effectively 0.005. Therefore, no mass is lost from the nucleus. Secondly, the atomic number. The atomic number increases by 1. And the reason for that is because a neutron is turning into a proton and an electron. So we're getting an extra proton. Thirdly, transmutation. And transmutation simply means a new element is made. We start with phosphorus, we end with sulfur. We started with strontium, we end with yttrium. We started with rubidium and we ended with strontium there. So those 3 key things are things you need to remember, as well as the fact that beta particles are electrons being emitted. So beta decay, very, very simple. It's just a process by which an unstable nucleus becomes stable by kicking out a beta particle. And that beta particle takes away mass, well, a tiny, tiny bit of mass, but a lot of energy from the nucleus, enabling it to become more stable. During beta decay, a beta particle is emitted. The atomic mass is the same, it stays constant, and the atomic number goes up by 1. And that's because a neutron decays into a proton and an electron, and that electron cannot exist in the nucleus, so it's kicked out. This word transmutation is important. A new element is always made. In your decay equations, all you need to remember is the symbol for beta, 0, minus 1. And the atomic mass on the left must equal the sum of the atomic masses on the right, so you can check that. And that the atomic number on the left must equal the sum of atomic numbers on the right. If you follow all these rules, you can't go wrong. That's it. Thanks for listening. See you all soon.